Welcome! In this series of short videos, we will look at topics for the PowerBasic Windows compiler. Today we will look at using a splash screen to give a user feedback on loading delays. As we covered in a previous introductory video, splash screens have a particular purpose. If when an application loads there is some delay before the first dialog appearing, it's very common to have a splash screen appear on the screen. Its purpose is to give the user something to look at and give them feedback that the application is actually still running. We can demonstrate this by use of a PowerBasic Windows application. We have a very simple Windows application here, the splash screen exe. If we double click on it, the dialog appears immediately. So with this application, a user would have no issues. As soon as the executable is launched, the dialog appears. However, if there was some delay in the application loading its first dialog, say for example the application was connecting to a database and pulling a large amount of data off it, then the dialog would be delayed coming up on screen, and there would be no feedback to the user that the application was indeed running. We can demonstrate this by having a look at the code. In our application, we have used PBForms to create a very simple dialog. Inside the PB main function, there is a call to the function which displays this first dialog. The first dialog does not have a great number of objects on its screen, and in the event handler, the callback function, we'll see there is nothing currently in the initialization handler that would slow the application down. So to simulate a delay in displaying this first dialog to the user, we're going to put a sleep command in here to give it a 5-second delay before the dialog actually appears. If we compile the application now, and we attempt to run it, we will see that now that we have actually clicked on the dialog, nothing's appearing on the screen, until the 5 seconds have passed and then the dialog appears. 5 seconds isn't too long for the user to wait. However, if there's a delay of more than 5 seconds, the user would start to question, has the application loaded? Has the application crashed? Does my computer need to be rebooted? So to save these concerns from our users, we use splash screens, or some kind of indication that the application is indeed loading. This could be at the beginning of the application, as we are looking at here, or it could be during some process within the application itself. So what we're going to look at today is the use of a static linked library. This particular library has been around for quite a long time, and has been created by one of the stalwarts of the PowerBasic community. So let's see how we can plug this static link library into our application and make good use of it. First of all, we will copy the static link library into the same folder as our source code. And there it is, zspin pb10.sll, a static linked library. So to make use of this static linked library, we need to put a call at the beginning of our application, using the link command. When our application compiles, this library will be compiled in with the code. So how do we make use of the library? I'm also going to copy in a new folder with 3 files in it. These are graphics files that are going to be used as our splash screen. Each of these is an animated graphics file. So how do we make use of this spinner library? If we have a look at our PB main function where our application begins, before the dialog is shown, we want to actually initialize our spinner. So in order to make use of our graphics, we need to actually make a call to one of the functions within the static link library. We can do that using our call command, followed by the name of the function, in this case spinner init, to initialize our graphic. We then have a number of parameters. The first parameter being the parent. Since our application has not loaded any dialogs yet, the parent will be the desktop. And then we follow that with the path to where our graphic lies. In this case it's in the same folder as the executable, it's in a subfolder called spin folder, and our graphic is called loading.ski. The final parameter is a 0. So this will launch our graphic onto the screen before we call the open dialog. If we have a look at the event handler, the callback function for a dialog, we'll see in here, after our simulated delay of 5 seconds, we will call another function to close down the spinner graphic, so that our splash screen will be terminated. If we make this the last call in our initialization dialog, then everything the dialog needs to load can be done before we close down the graphic. If we compile that now, and if we attempt to run our application, we'll see that a small animated graphic appears as a splash screen, which will wait on screen for the 5 seconds delay. Then our dialog can be loaded. This way, regardless of how long it takes for your dialog to load up its data, the user will have something to look at to give them feedback that the application is in fact doing something. While this works well, it does give you the disadvantage that your executable needs to ship with a subfolder containing some graphics. How can we get around that? Well, what we're going to do is we're going to embed the graphics within the application. At the moment, there are 3 separate graphics files within our spin folder. You may not need all 3 in your application, you may actually only need 1. But for the moment, for this demonstration, we'll put all 3 in. What we're going to do is use a resource command to store these graphics at compilation time within the executable. So we use the resource rcdata command, followed by a unique identifier. We're using 4000 for the first graphic, and then 4001 and 4002 for the final graphic. And we're giving it the path to where the graphic exists on our source code at compilation time. This will embed these 3 graphics in the executable. You can easily tell that this has happened by looking at the size of the executable. At the moment, it's 71K. If we compile it again and have a look, we'll see that our executable has now jumped to 264K because we have included each of these graphics. So having got the graphics into the executable, how do we get them out at runtime? Before we call the function within the spinner library, we'll need to save these graphics back to somewhere on the disk of the computer that's running our application. So we're going to create a new function to save our spinner graphics. We'll call this new function SaveSpinner. There are a number of places we could actually save these graphics, but I'm going to save them to the Windows temporary folder for the user that's currently signed on. So we're creating 2 local variables, a handle for the file we were about to create, and a string variable to contain the contents of our graphic file. We will perform the same task for each of the graphics. The first thing we need to do is to extract from the executable the data which is our graphic. So we're going to extract the graphic whose handle is 4000, and using the resource $command we can populate the string variable. This strSpin variable now contains the content of that file. All we then need to do is to save that file to disk. We can do that quite easily using the standard open for output. First of all, we determine the next available file handle, and using a try catch, we will then open, and we want to designate the temporary directory. We'll create a function for that in a moment, but all we need to do is say we're going to save the loading SKI file for output as our file handle. And then using the print command, we're quite simply printing the value of that variable to disk. We're following the print command with a semicolon, because if we did not use the semicolon, there would be a carriage return line feed printed into the file at the very end. So using a semicolon stops that happening. And then finally, we're closing the file. We will then perform exactly the same function for the other 2 files. So what we need to do now is to create this fun temp directory function, which will determine where the folder is on your computer for the currently signed in user Windows temporary folder. This is using one of the Windows API calls, getTempPath. This quite simply takes no parameters and will return a string which is a path to the Windows temporary folder. So now that this infrastructure is set up, we now have to amend the call in our pbmain function. The call in the pbmain was taking the graphic from the XePath spin folder location. We merely have to amend that now to make use of the temporary directory, like so. The temporary directory function will return the folder in which our SKI file is actually located. So if we compile that now, and if we run the executable, it will run and load quite happily. So we have embedded all three of these graphics within our application. So we no longer need to transport the spin folder and its underlying graphics with the executable when we release the application. So if we amend this call to try out the other files. We have a circular graphic, and the final one is the gears graphic. It being a bigger graphic, it does display more prominently on the screen. And there is our application loaded. So as well as using this spinner library to display a graphic when our application is loading, we could actually call this when the application is actually running. Say for example, we added another function on the next button. If we have a look at the callback function, it's not doing a great deal. If either the OK or the abort button are actually clicked, the application will end. If we simulate some other function happening, when the OK button is clicked, we will sleep for 5 seconds and then we will display a message box. And while that's running, we want to display to the user on screen one of our graphics. We can do that easily by using the spinner init again. We're going to be using the loading graphic, and after the 5 seconds has elapsed, we're going to be closing it down again. As we now have a payment dialog, we can substitute the first parameter for the handle of the payment dialog. So if we run our application now, we will get the gears initially while the first dialog loads, and when that is completed, we will click on our next button. We will then get the loading for another 5 seconds until the message box appears. So using this very useful static link library, you can put splash screens, albeit mini ones, within your application and at the beginning. In our next video, we'll be covering other forms of user feedback like progress bars and graphic screens. But that's it for today. Thank you for watching.